No, but you just do it. You know, it'd be great.
Like with the work.
The answer key is complete.
We're watching movies after the AP test.
Yep. They have to be like PG. If anything, even though you're all above 13, I need
Hey, if I let you use my HBO Max, you watch Batman.
give you anything
All
above.
right, Ms. Jordan, do you have HBO Max?
Do I have what?
HBO Max.
I do.
Instead of district
We
rule.
can watch Batman.
No, Batman is.
Is the PG
No, it's PG.
insert thing or what?
So in order for me to show you a PG-13 movie, I would have to get parental consent. Doesn't matter. It's illegal. Oh,
I'm 18.
consent for PG-13. Yeah.
Evacuate the room.
But look, guys, y'all are sleeping on so many good movies. Okay, there are Disney movies, Pixar movies. Yes. Oh, Dad is watching. That's where the guy's that kind of he turns into an evil man or something. Moon, that's the superhero guy, and he's kind of evil. I do mean Moon Knight.
I'm talking about Moonfall, where the leaves about to fall to the earth.
I don't even know what that is. I've never heard of that in my life.
But I watched the last like 5 minutes of it because my mom was like,
we didn't have to watch
Yeah, we watched Kick-Ass.
They better have done it for
Okay,
parental consent.
Let's watch 50
This
Shades.
winter when Bad Moms came out and I was like 9 years old, my parents took me in theater in the front row to go and see it. I do not think they care if I watch a PG-13 at 18 years old.
Grade, we watched the 1996 Romeo and Juliet, and we did not have to fill out a parental consent.
With the girl's titties out.
I feel like
I record. Speaking of titties, here's what I'll tell you. I love to follow the rules because if I ever don't follow the rules and they ask me about it, I'm really bad one.
What are you gonna do?
I
fire you.
I'll think about it. But also, there's additional copyright laws that state I can only show you a movie if it's academically relevant to the content we're doing.
Batman
Girl,
teaches us how to do- Batman will teach us how to do riddles.
So I'm already sliding some.
Let's watch Moonfall. It's a good movie.
I will look up the
It's on Amazon Prime.
rating, the mom ratings.
How about every single movie is math related because it took math.
Let's watch
to
Monty
learn computer
Python and the Holy
science to
Grail.
make it a digital.
Wait, Ms. Jordan. Ms. Jordan. Ms. Jordan. You should watch Monty Python and the Holy Grail.
Absolutely not.
What? Come
That's
on.
the one where they cut the guy's arm off.
Just put a scratch.
And his other arm off.
I know, pull it up. Pull it
A
up.
flesh wound.
It's just a scratch. Your arm is off. What are you gonna do? Put it on me?
So, yeah.
Probably.
But we
You guys are
should
good at
have
that.
like certain things in it.
We
that
should watch
schools
Deadpool.
Have to get.
Yes. Wait, which one? Deadpool 1, 2.
I mean, one first. You can watch them both. But you don't
Okay.
care.
But for now, we're far away
Deadpool
from
2
these
is
movies.
I'm gonna review half.
Deadpool 1 and then
I'm gonna review half.
All right.
what packet is that?
So this is a general review.
Oh,
Where is this packet located? Because you just handed me 3.
it was at the front
Oh,
desk.
that's the one you were supposed to
Wait,
pick.
is this packet 2? Oh, wow. That's
We're working on this today and Friday.
Oh, this is like a. I thought we were doing other stuff.
Yeah, so here's the deal. Okay, so, huh?
For this?
No, we're doing that in class. Okay, so let me clarify, because some of us seem a little confused. The only thing you have to turn in, other than the Delta Math, which has already been due for like a week. Okay, other than Delta Math, all you're gonna turn in are those 3 packets: AP review on limits, AP review on derivatives, AP review on integrals. That's it. So, okay,
These are mandatory?
they're major grades, so that, and you have the keys for all of those.
I thought that was optional if you were missing homework assignment.
Yes.
Oh, dang.
Yep, they're all right there. Okay, so, but listen, the reason that we're doing a general review this week is because if we only hit one topic at a time, then you would end up missing stuff. First, if we just generally review all of it mixed up, that's how the AP test is gonna be. And then starting next week, you guys could be out for various different things. If you're taking the AP whatever test, you might be gone on one day to be at class. So nothing that we do in class is for a grade, but I'd really love for you to just buckle down and do your best, okay? We're all in this together, okay? Yes. Yes? If it's a field trip, no. If it's an excused absence, then yes, if it wasn't like a school.
Since when?
But let's dive in. Come on, guys, make a dive into the waters of. Okay, so ready?
Shallow end or deep?
We're in the deep, deep. Okay, which of the following is false? Look at it. Okay, and then I'll call on you to tell me whether you think an answer is true or false. Letter A, let's go with Paloma. The limit as x approaches to, true or false? It exists or not? Okay, it is true because as I approach from the left and as I approach from the right, I'm approaching the same y value. Does it matter that there's an open circle there?
No.
No, so that's true. We want the one that's false. Okay, second one, x approaching 3. Let's go with Cindy, true or false? Be brave.
I'm not brave.
You know.
We're a bunch of cowards.
So you say the limit doesn't exist. As I trace this way and this way. That's true. Okay, next one, x approaching 4. Let's go with Denishman, right down the line. True or false? Okay, that one is false. Why does the limit not exist? Well, the left and right limits both exist, but they're not what? They're not the same. So let's write that out just to practice. So the limit as x approaches 4 from the left is equal to, we'll say maybe 1.8, because it's not right at 2. Okay, but what's the limit from the right? 4. We'll say 4. Okay, but because they don't match, that's how we know that that one's false. Okay, then x approaches 5 is obviously true. The function is continuous at 3. Now, someone asked in the other class, they were like, but wait, at 3, there's a cusp. Okay, does a cusp mean it can't be continuous or connected? No, what does it mean it can't be? Not differentiable, perfect. So I want you to circle right here. Okay, the cusp is continuous. Okay, but what it's not is differentiable. And remember, differentiable means that you could draw me a tangent line on the graph and you could find the slope of it. Okay, so that's the problem with cusps, is you can never get your line on there to really be tangent. Same thing with corners. Okay, go down to the next question. You'll notice the numbers of these are all crazy because I just pulled them off of AP exams. So next one is number 9. Okay, it says, what will make my function continuous at 2? It's a piecewise function. What has to be true for it to be continuous? Okay, both of the limits have to be equal. That's exactly right. So I'm going to take the top and the bottom, and I'm going to say, okay, well, if this is going to be continuous, then those have to be equal. Now, as I set them equal, what value do they need to be equal at? Just at the breakpoint, which is a 2. So then I would say, okay, this doesn't have to be true everywhere. It just has to be true at. So then from there, I go to plug in 2. What happens on the bottom?
0.
You get divided by 0, can't have it. But this one's even already factored for you. Okay, what could I do if I see a repeat factor in the numerator and the denominator? Okay, cross those people out. And then all we're left with is 2x plus 1 equals k. What's my x? So then what is my k going to be?
5.
Okay, k is going to be 5. There you go. All right, next one, horizontal asymptote. How do I find a horizontal asymptote on a graph? What rules?
The biggest power.
Okay.
The numerator and denominator attached to the biggest power.
Yes. So do you remember the Bobo Bot and Betsy? So if it's a bigger power on top, then you're not going to have one. The N stands for no horizontal asymptote. Okay, what about if it's a Bobo and it's bigger on bottom? Then what's the asymptote? It'd be y equals 0. Okay, but if I want it to give me a number, then that's your Betsy option, which is where they have to both be equal, and then you're going to divide whatever the number is on top. We'll say ax to the n over bx to the n. Okay, but these would have to be equal. So look through your answer choices. Which one of those has an equal power on top and on bottom? And what do I want the asymptote to be in the question? Y equals 5. So which one would that be true for? Okay, D is almost right. What's wrong with D? What's 5x divided by negative x? That would be what? That'd be a negative 5. So that's almost what we want, but not quite. So we can't pick D. Then which one will we pick? E. And look at E. Remember, they don't have to put them in order for you. You just have to look for the highest representative on top, highest representative on bottom. So if I pick 20x squared over 4x squared, then what does that divide to? 5, which is what we want. Now, so E is the correct answer. I want you to take a look at C. C also has an asymptote at 5, but what kind of asymptote is it? Okay, anything that makes the bottom 0 is a vertical asymptote, which means it wouldn't be y equals 5. What would it be? X equals 5. Okay, and so just remember the difference there. Bobo, bot, and Betsy are for your horizontal asymptotes. Okay, and then bottom equal to 0, those are your vertical asymptotes. All right, turn the page when you're ready. Let's keep going. Doing great, doing great. Little bit of limits, little bit of continuity. Next question, we're gonna skip 18. We'll come back to it. Just go to 7. Okay, you have a function, you want y prime. What do? Take the derivative. What rule are we doing here? Your choices, product, quotient, or chain? Chain, because what's the outside layer? Everything in the middle is raised to the 5th. So let's do it. The 5 is going to come down to the front. What happens to the middle at this step? It stays the same. So x squared minus cosine x. What's my new power though? To the 4th times. And then what do I put at the back? Take that x cubed minus cosine x, and we're going to times the derivative behind it. So it'd be 3x squared. What about the minus cosine x? And then look at your answers. Which one do we want? Okay, E. Now, one quick thing here. Do these parentheses have to be here for your answer to be correct? Yes. Yes. Now, if it's multiple choice, how are they going to know? Right? Nobody's going to know. Okay, but I'll know because I'm always going to be watching. Okay, when you take your test. Okay, next one.
I got some. Like the monsters being funny says I'm always.
Yes, my Wazowski. All right, look at number 4. Now we have F. We want F prime of 1. What's the difference from your instructions here to your instructions here? Here I just want a derivative. Here I want a derivative and then plug something in. Okay, but it's the same thing. So do it. You have your function right here. Are there any derivatives we don't remember? 1 over x. We're on the back of the first page. So if I had 7x minus 3 plus ln x, the only one I would expect you might have forgotten is the derivative of ln x is 1 over x. So if you want to write that down. So what would my derivative be, huh? We skipped 18. It is 8. Very good. So your derivative would have been 7 plus 1 over x. What happens to the minus 3 if it's a constant? Gone, goes to 0. Then f prime of 1 would be 7 plus 1 over 1, which is 8. Check. All right, go to the next one. Now, this you might have forgotten because we haven't done this since like December. But it says we have a function f, and then g is the inverse of f. So what I want you to do is make our little chart. We're going to put f of x on the left. We're going to put g of x on the right. There are two relationships that you have to remember about inverses. The first one is that their ordered pairs are backwards. So if f of 0 is 1, what is f's ordered pair? 0, 1. Then what would g's ordered pair be? 1, 0. Because remember, inverses, the domain and range are just swapped out. Okay, the second thing that you should remember is that their slopes are reciprocals of each other. So if I know the slope for f, all I have to do is flip it for this side. So I'm going to put their slopes are reciprocals. So if I know the slope over here, then I can just flip it to find the slope for g. Now let's think about how could I find the slope of f if they gave me the equation. If it was linear, I could do that, but how would I find it if it's a curve like that? What's the same as a slope? Yeah. So let's do it. F is here. What's f prime?
3 times 2x plus 1 times 2.
So to squared, and then why are we saying times 2? Yeah. Okay, now that's the slope anywhere. I want the slope at x ordered pair. What is f's x value? 0. So then I would find the derivative at 0. Well, then that would be 3 times 2, that's a 6 in the front. And then 2 times 0 plus 1, and then we're going to square it. What is 2 times 0?
0.
Add 1 to that. What's 1 squared? 1 times 6? 6. So if my slope over here is 6, what's my slope over here?
1, 6.
1, 6. Make sense? It's for perpendicular lines that you change the sign and flip it. For the slopes, you only flip, don't change the sign. So if you want to put here their same sign reciprocals. So if that slope was 6, then this slope is 1, 6. Now I want to point out one more detail to you before we move on. When did they want g prime? 1, and even though 1 is the x value for g, is that the x value I use for f? No, because they're inverses. So they're going to give you g's x value, but that's really the y value for the other. Okay. All right, turn the page. Next one. Okay. We have a function, and we want to know when it's increasing. What are we going to do?
Positive.
Positive what?
Slope.
Okay, positive slope. And what's the slope? Slope's taking a derivative. So take the derivative. Okay, all the things you're going to come back to today. You're going to remember everything, okay? And especially Alyssa, because she's looking really excited about this. Am I right, Alyssa? Okay, if you need to take a nap, it's okay. Just take a nap. Okay, so 300x minus x cubed. What are we going to put for our derivative? Let's go with Lul. Tell me that derivative.
It's like race game shows.
Not the first game show. You would be so lucky as to be Okay, 300 minus 3x squared. Good job. Well, then what do I do next, people? Set it equal to 0 and factor. Wow, you're both right. Okay, then what do I do next? Take out a 3. What's left? 100.
Wait, it'd be like negative.
Okay, so you have 2 ways that you could do it. If I take out a 3, then my order is backwards, but I can still factor it. What's the square root of 100? Square root of x is, or square root of x squared is. So then when you do your thing, you just have to make sure that you keep it in the same order. So it'd be 10 plus x and 10 minus x. Now, if you wanted to do what my said of taking out a -3, that's fine. But then instead of the 10 plus x and 10 minus x, it'd just be reversed. But overall, it's the same thing. What are my critical numbers? Okay, -10 and 10. And then what do I do after that to check for the signs? Do you remember?
Make that little line.
Make a sign chart and plug into where?
Original?
Nope. The derivative. Because remember, we want to see if the slope is positive or negative. So let's pick a number bigger than 10. Say we pick 11. 11 plus 10. 10 minus 11. Negative. So this one came out negative. Are there any double roots?
No.
Then that means it's going to switch every time. So negative will switch to a positive, then we'll switch to a negative. Which means if those are the signs for f prime, what is f doing? It'd be
Decreasing.
yes. And then we want the number line that's increasing, so we would pick B. Huh? Yes. See, we all have these units we did really well on. Keep the memories, okay? We're gonna skip 26 and come back to it. That's about it. Okay, we'll come back to it. So skip that one. That really derailed 3rd period. So we'll come back to it. We just all got really confused, so it's okay. All right, next one. What is this a graph of? Okay, this is f prime, and they're asking me questions about f, the graph of f, the graph of f. So is this the graph I'm answering the questions about? No. So if this is f prime, where will I find my critical numbers? Okay, for my x-intercepts, when the derivative f prime equals 0, which means I have how many? 2. I have 1 here and 1 here. Now, take a moment in your mind and label one of them as a min, one of them as a max. Think about which one's which. Remember, the order of the sign change is what makes it a min or a max. Okay, so if it goes negative to positive, what did you outline? This is a min. And then what about for the second one where it goes from the positives to the negatives? That would be positive slope to negative slope. That would be a max. Okay, the other question I had for you is that if f prime are the y values of this graph, what will f double prime be? It would be the concavity if this were f. This will be the slope of this graph. So if this were f, yes, f double prime is the concavity. But if I'm already looking at the derivative, then f double prime would just be the first derivative of this graph, which would be the slope. So I want you to mark with an x where your concavity or your slope changes sign. How many x's should you be putting? Where does my slope change sign? At 0. Because all the way on this side, what's my slope? On this side, positive, and then what about on this side? Negative. So I would have a point of inflection at 0. All right, now let's look at our answers. Let's see what we think. First one, statement 1 says f has a minimum at -3. True or false? Statement number 2, we have a point of inflection at -2, true or false? Okay, that is false. And then third one, F is concave down on 0 to 4, true or false?
We don't really know yet.
What is, okay, concavity is F double prime. What is F double prime here? So you say it's true or false? Sure. Okay, think about it again. Is this the graph that's supposed to be concave down, this picture? No. So how do I know what F's doing? I'm looking at this guy's slope. And I see that from 0 to 4, that whole time, my graph is downhill. It has a negative slope. Does that make sense? Yeah. So then we want statements 1 and 3. We're choosing answer E. Okay. All right, go down to the next one, number 90. We have an integral 6 to 12, f of 2x dx equals 10, which of the following must be true. What do you notice from f of 2x to all of these answer choices? Is it still a 2x in the middle? Okay, then we're doing u substitution. So let's do it. What do you guess you should pick as your u? Okay, do it. And then rewrite this integral in terms of u. So I'll give you a sec to do that. So pick your u. Your u is 2x. Okay, then v, what's my derivative of that? Just a 2. And then remember, I times my dx up, I divide my 2 down so that it's a du over 2. Okay, then from there, you're going to rewrite your integral in terms of u. So instead of f of 2x, what is it going to be now? F of u. And then what's going to go where the dx is? Du over 2. Where can I put the over 2? 1/2 outside. Now, what are we forgetting? There's one other thing we have to remember. The endpoints. Good job. That's exactly right. And where do we get the new endpoints from? You plug them into. So my original top endpoint was a 12. What is it now when I plug it into a 2x? 24. My lower endpoint was a 6. Plug it into the 2x. Now it's a 12. Okay, now this integral is the same as this integral. Then what is it equal to? 10. So this statement must be true. Is that statement present as an answer choice? No. So how could I make my answer look like one of those answers? Yeah, if I want to get rid of this half in the front, I'm just going to times it across to the other side. So if half of this is equal to 10, then what is the whole thing equal to? 20, because you have to reverse it, right? So if half of this is 10, then this part is 10. And then what answer are we picking? B. Now, somebody in the other class was kind of like, but wait, they didn't use u's, they used t's. It doesn't matter. They could have put thetas there and it would be the same thing. As long as your letter in here matches your letter that's here, it doesn't matter. So instead of doing u substitution, they did a t substitution, but who cares? All good on that? Okay, so you have one more u substitution question down here. Okay, see if you can do it. You can do it. Let's go. Yeah. You can do it. Yeah, so you'll pull the 1/2 out and then there's 1/2 of the extra. Half. Yeah. So we bottom off. No, so when you plug in 5, you get 0, but what about if you plug in 0? What's 25 from 0? Do the same. Oh, wait. I don't remember how that was, and then change this to you to half so that you can read it. Okay, your d is over negative 2x. And then what's gonna happen with that x and the x over there? So now what can you pull out to the front? Negative 1/2, yeah? Negative 1/2 because the x's should cross out. Remember the x that was in the front here? All right, so most of us seem to pick this part right. So 25 minus x squared, then the derivative of that is just a negative 2x. Then we times our dx up, divide our 2x down, so it's du over negative 2x equals dx. Rewrite time. Integral, we have an x in the front. And then all of this in here is our u now, so it's the square root of u. And then our dx is now a du over negative 2x. What has to cancel out or you picked wrong? Okay, you can't, some of y'all I saw were trying to pull the x to the front. Remember, only numbers can get pulled out. So these have to cross out or you couldn't work the question. Okay, then from there, we're taking out a negative 2 as a fraction, so it's a negative 1/2. How can I rewrite the integral of square root u? 1/2 du, very good. Okay, then from there, we should have changed our endpoints. So if I plug in 5, what is 25 minus 5 squared? What about if I plug in 0? 25 minus 0 is just 25. Now, in the other class, somebody had said, well, the numbers are backwards. Can you switch these if you kill this negative? Yeah. Sure, if you want to, but you don't have to. Okay, so I'm not going to, but you could. If you reverse the order, then you just change the sign on the integral, just like we've always done. Okay, from here, add 1 to the power. What is 1/2 if you increased it by 1?
3/2.
U to the 3/2. Then I have to divide by 3/2, which means I'm multiplying by 2/3. But then I already had a 1/2 in front of that, so it's going to happen. Yeah, negative 1/3. Okay, then from there, what numbers are we plugging in? Yeah, so we'll do 0 and 25. Yeah. Okay. But remember, why don't we have to go back to the x stuff? Because we changed our endpoints. So then from there, plug in a 0. What is negative 1/3 of 0 to any power? 0. What about if we do negative 1/3 of 25 to the 3/2? How do I work this out? This power you should know how to do. The 2 on the bottom means it's a,
50.
oh, hold on. 2 means not divided by 2, it's a 1/2 power. What's that the same as? Square root. So I'm going to do negative 1/3 of the 2 is a square root 25. And then I'm going to cube it. Do you remember doing that? Yeah. Okay. So then square root of 25 is 5 cubed is, and then I have negative 1/3 of 125. And then what do I do with these two values? Subtract. So if it's 0 minus negative 125, then my answer would be positive 125 over 3. Yes, Luke?
We did the integral of 55.
Say that again.
We did the
So remember your original endpoints, you have to plug them into what your U is. Otherwise, when you get to here, you have to change your U back to the 25 minus X squared. So what I did was I took 0 and 5, I plugged them in right here. And then I changed the endpoints when I switched it to U. Okay? Because when I plugged in 0, 25 minus 0 came out to 25. So now remember what I said though, if you want to reverse the order, you just have to remember to reverse the sign. So I do think if you thought of that on the AP test, that probably is a little bit easier.
So it's negative 125 over 3.
No, because it's 0 minus negative 125. So do you remember with the endpoints you subtract them?
Yeah.
That's okay. All right. Hi, Gracie. Okay. That's okay. Yeah. Good to see you. All right, ready? Turn the page. Poke your neighbor if they're asleep. Just give them a little gentle poke. Yes, sure. Here we go. You guys are doing great. Y'all are doing great. Yes, you can go to the bathroom. Just take the bathroom class. Okay. All right, next one. All right, this one is a little bit tricky, but I want you to think about it and come up with a plan. We have a piecewise function. When do we switch from one function to the other? What X value? Okay, at 3. But then what do we want to integrate from? 1 to 5. Okay, so think about, if I integrate this function, I have to break it up into 2 pieces. First, I'm going to integrate from 1 to 3 using which function? The function 2. And then I'm going to switch to the other function, which is what? X minus 1. And then I'm going to pick up there at 3 and I'm going to integrate until 5. Does that make sense? Because you're not using the same function the whole way across. So you would have to kind of like section it out to go with the domain. So from 1 to 3, I'll just use a 2. And then from 3 to 5, I'll use the X minus 1 graph. Okay, now, if you were good at geometry, you could do these by graphing it, but we already know fundamental theorem. So what's the antiderivative of 2? 2x, what do I do with the endpoints? Just plug them in and subtract. So f of 3 would be what? And f of 1 would be 2, and then 6 minus 2 is 4. Now remember, that's just the straight line area. Now we're switching to the x minus 1, which is your linear piece. What's the antiderivative? Minus 1x. And then we're going to plug in our endpoints, which are 5 and 3. Okay, I'll show you a little trick on this. I'm not sure if we've done it or not yet, but watch. We're plugging in our 5 first. What's 5 squared? So we have 25 cut in half. And then plug in your 5 here. That's a minus 5. Same thing with 3. Plug in your 3. What's 3 squared? 9. So I want half of 9. So I'll just put 9 halves. Minus, and then plug in your. Okay, at this point, what a lot of times I see kids do is they try to get common denominators in both of these before they subtract. Okay, but if these are both halves, then let's just leave it as is and subtract them like that. So I'm going to have 25 halves minus 5 subtract 9 halves minus 3. And then subtract the pieces that are the same type of thing. So for example, what is 25 halves if I minus 9 of the halves? And you know what 16 halves is, what 16 halves? Just an 8. And then I'll do the same thing with the whole number part. What's negative 5 minus negative 3? -2. And then what's 8 minus 2? 6. So if the first chunk of the area was 4 units and the second chunk was 6 units, then what would your total area be? Oh, wait. 10. Yep. Make sense? Okay, number 3 is just to memorize it. Maybe you know it, maybe you don't, but let's just write them down to try and help you remember. Okay, what is the derivative of tan x? Secant squared. Then if I wanted the integral of secant squared, I would go back to tan. Do you remember that? Okay, now what was the derivative of secant? No, it's secant. Okay, so now think about if the derivative of tan, or I'm sorry, of secant is secant tan, then what would the integral of secant tan be? Back to secant, because remember, they're the same rules, they're just back. So if I take the derivative to get to secant tan, then the antiderivative would bring me back to secant. Does that make sense? Yes. So just like the integral of secant squared would bring you back to tan, the integral of secant tan would bring you back to.
So we just have to know this.
Yeah, and then remember, as we've been going, you guys have that pink sheet, and we've been kind of like slashing out the rules that are less likely. But if you look on here, remember that both sides are the same, they're just reversed. So like on this side, you have the derivative of sine, cosine, and tan, and then if you flip it over, you have the integrals for sine, cosine. So remember, you're really only memorizing one side of it. Okay, but if you were going to pick ones to memorize, definitely secant squared and definitely secant. Okay, great. Do we need a little move around water break? Yes, okay, so let's get some water, get up, go to the bathroom. Here we go, doing great. I don't know, just to get through what we can do. Yeah. Mhm. Did that one die on you?
Yes.
You know the trick? And then it all goes to the tip. You know? I think that one actually. As you can see, I do.
This one is good.
This one's good.
Wait, what? Usual or
Both of the purples are running low. I need to get some more pens. Are you not gonna text Gracie? She wants you to text her so bad. Huh? Oh, you did? What is that? Dallas Heavy Duty Coach? Design and create. Oh, it's for district. Yes. Development. It could be developed. Did you get the word? Did you get the one that was terrible like 2 days ago?
I haven't done it. This is the first day I've done it in like 3 weeks because I missed one day and I lost my like 1 month streak.
Yeah.
I have to try.
Or a skew.
A skew.
I like the skew or the,
I like ties.
I use the word.
I like when they have a two vowel.
How many times would you say you use a skew a month?
Maybe
It's really
one.
messy. When my mom asks how my room looks, I just say it's a little askew.
See, I like to say disheveled. Skew those to me, just like, oh, that page is a little askew. Like, you know, not lined up.
My chakras are.
Your what? Your
Chakras.
What's your starting word?
Huh?
What's your starting word?
change it. Chad's is grave.
A V.
I know,
On a
I'm like
C?
stupid. But he loves, and now Ashton uses it. I'm like,
Mine's chaos is at HOAS. So just
Yeah.
those common functions.
That's a solid one.
I think I'm gonna start using the previous stage word as my starting word.
I used to do that.
Oh. Do you have it in hard mode? Hard mode, you cannot like use any information you've ruled out. And like, if you know, like there's an E at the end, you have to put an E at the end of whatever word you try. So it like, yeah, you can change it.
That's always how I get the word like 3. It's like I take my first one, the first one, then put all different letters in the second one.
Yes.
And then put together a
I
word.
like doing that too. But if you change it into hard mode, no longer an option.
I do like 8-letter word also.
Yeah.
It's hard.
They make a version of 8 letters?
Not the Wordle brand, but there's like an app, you can do anything from a 4-letter Wordle to an 8-letter Wordle. And then there's like a specific website where you can talk like 10 or 12.
Wow.
Really stressful. There's a website called Wordle where it's 4 Wordles and you can only enter 1 word. And there's 4 words. So as you enter words, you get chances with all 4 of them and you have to guess all 4 words.
I have a question. What is Bongo?
I don't know.
You know, the
It's like a game
librarian
that you
does a
usually
Bongo.
Usually play it with like, it's a physical game with like dice, like you move around the dice and they fall into a little.
So, but what's her Bongo?
It's just, they give you the like grid of
Yeah.
letters and you have to connect them like you're playing words with friends. Have you ever played words with friends?
Isn't that just Scrabble?
It's kind of like, no, it's not really Scrabble.
It's based off of Scrabble, but it has like different rules.
Different dice, the letters on it, hit the thing a lot.
But then what are you trying to do?
Or you have to connect them like the letters that are connected. You have like your baseline letters. So like right now, the ones that are downstairs, you can do like cow, you can do curry, you can do like, what's another one? So,
Oh, so they
meow.
can go
Yeah, you
diagonal
can go diagonal.
or like this way.
Or like that,
Like
but
that's
you
a
can't
word.
like double back and use the same letter twice. Unless the same letter's in there twice.
All right, are we ready? Yes, let's keep going.
Honestly, I feel like as soon as you say that, it's like the suit just.
Oh, it's okay, guys. Less than 2 weeks. Okay, I'll see you only a few more times.
I was playing Wordle with friends, we just put some response in the middle, and you all just guess for it. Wait, you supposed to?
Yeah, of like actual pastime. What is your?
Wordle with friends, where you just, someone pulls up word on your phone, you put the phone in the middle, and you all try and guess.
Oh,
It involves a lot of guessing.
wow.
I would say, you know that.
I've never seen this game.
It is an
version. We'll play it after the AP test. Sounds great. Okay, are you ready? Come on, guys. Yeah.
Can I have like 2 more
I'm
minutes?
almost done.
With what?
Okay.
Okay, I'm done.
Oh, nice. Okay, perfect.
2 minutes.
You can take 2 minutes. Okay, water pumped into a tank at a rate of blah, blah, blah gallons per minute. Then it says T is the number of minutes since the pump was turned on. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? How do I go from gallons per minute, which is a rate, just back to gallons? What do I have to do? The antiderivative or integral, right? Now, when am I going to integrate from if I want 20 minutes?
Oh.
What are my endpoints going to be? Huh? 0 to 20.
That 0 is 800, right?
Okay, perfect. Yes, hold on to that thought. So then we'll put our 31 minus e to the negative 0.16 t. Okay, now if you didn't hear what she just said, she said there are already how much gallons of water in the tank? 800. So this is going to tell me how many new gallons came in entered the tank or whatever it is. Okay, but then we would have to remember to add the ones that were already there. So you'd have to take your 800. So A and B are already wrong because there's no way that stuff came into it if you already had 800, so that's true. Okay, and then where would we do this calculation in the calculator? Okay, I'll even do it for you. Math 9, oops, math 9, 0 to 20, 30 parentheses, 1 minus e to the power of negative 0.16x. Don't need that, dx. Okay, we got 420. 420, is that my answer? Okay, that's without the 800 that were already there, so then we would add that up and get 1220. Make sense? So point of that example is, don't forget that when you integrate, you're getting how much water flowed in, but if there was already water in there, you need to include that as well. So technically, I just want to show you this for the next example. This is a version B. Here's what you would have said. I want to know how much water when there's 20. I know how much water there is at 0. And then I'm going to integrate the gallons per hour function, or gallons per minute, technically. Okay, so this is what I want, is the water at 20. I have it already at 0. There were 800. And then this would tell me all of my new gallons. Do you remember doing that? Okay, so we call that version B, but it's the same thing. Okay, so now turn the page, see if you can set up the next one. Okay, you can do it. Set up the next one. What's in your chart? What units? Okay, liters per hour. How do I go from liters per hour back to the number of liters? Okay, so set it up. You can do it. Okay, we'll say the amount of liters, you can call it, I don't know. Okay, good. Ignore the Riemann sum for right now. Just set up the version B. It's this. It's S of B equals S of A integral A to B. That's your version B. Want, and the A is what you already know. Okay, any of you, will you tell me your thing? When do we want the oil? What time? 15. When do we already know the oil? We know it at 4, and then what are we going to do? Integrate from 4 to 15 of our rate. Okay, now how much was in there at 4? We already know this number. The tank already contained 50 liters of oil at 4 plus. And then the problem is, look at your question. Did they give you the integral to type it into the calculator? No, instead they gave you a chart. How do I do integrals from a chart? I'll have to do it with Riemann sum. Now remember, there are 3 types. There's a left, a right, and a middle. Which one did they want us to do? A right Riemann sum. So the Riemann sum is for you to know what to do with this. So quick question on Riemann sums. Look at your delta x. Is it jumping by the same amount every time on the x-axis? 4 to 7 is a jump of 3, but then 7 to 12 is a jump of 5. So can we do the short version? No. So remember, your Riemann sum is going to be the width times the y value. And then the width times the next y value. Okay, and each one of those is a rectangle. So you have a width, which is your delta x, and then your height on the right side. So what is my first width from 4 to 7? 3. And which of these y values is on the right side? So I'll do 3 times 6.2. Second interval, I'm covering 7 to 12. How wide is it? What is the right Y value? And then my last one from 12 to 15 is 3. My right side Y value is 5.6. Okay, and then remember, you anytime you see a right Riemann sum, which Y value gets skipped? And what if it was a left Riemann sum and you skip the last one? Okay, and then I added it up. I think 50 plus 3 times 6.2 plus 5 times 5.9, 3 times 5.6. It's 64.9. Answer choice 4. All right, look at the next one. Very carefully. See if you can do it. This one's a little bit tricky, but think about it. Think about what's in the chart, what numbers they gave you. Is there any number we can definitely get rid of? Okay. Okay, it's positive the whole time. Now let's think about this for a second. I actually want you to draw this. Let's draw a little graph here. What is this a graph of? F prime. Okay, so at -2, we'll say we're at 3. That's one point that I have. Then at 0, I'm going to be at 1. At 1, 2, 3, I'm going to be at 4. Doesn't have to look perfect. Then at 5, I'm at 7. And then at 6, I'm down to 5. Okay. First question. So let's talk about the critical numbers. It says, which of these must be true? Can you promise me that the graph doesn't go like this? Watch. Can you promise me that doesn't happen? No, because we only have a couple of points. So could I have relative extrema on the graph? Do I have to have only 2? What about if it did this? Then how many would I have? Okay, so look at this. What if I went like this? Down, up, down, up. Now how many critical numbers would I have? 4. So you can't promise me there are only 2. You can't promise me there are only 4. Can you promise me that it's always going to stay positive, even on the little sections of the graph that I'm missing? No. So let's look at the last 2. Do I have to have at least 2 points of inflection? Well, what feature is points of inflection if this is F prime? Increasing or decreasing. So think about it. If I have to have at least 2, what happens from 3 to 1? I went down, and then from 1 to 4, I went up, which means I have at least 1 point of inflection somewhere in here. I don't know where. Then I keep going up until 4, but then what happens? Down to 5 means I have to have at least 1 more. So this one was a little bit tricky because the graph is for F prime in the chart. But remember that you can still know stuff about concavity using the slope of that graph. Okay, so just make sure if it says what must be true, you got to think about what about all these little pockets that we're missing information on. Could it dip into the negatives? Maybe, we don't know. Okay, get it? Next one, here we go. Look at it. This is H, integral 0 to x of f. What's the graph of? Okay, this is f, and h is the integral of that graph. What feature would tell you an integral? area. Okay, that would be area. All right, now what if I took the derivative of h, but h had an integral limit? This is kind of old. But what do you do with the letter? Do you remember? You remember that? If you take the derivative of the integral, they cancel each other out, but you have to switch out your letter. So now instead of f of t, it would just be f of x. What feature in the graph is f of x? The line or the y value. Okay. Then one more derivative from there for h double prime of x. What would the derivative be of f? It would go to f prime, which is the slope. That's exactly right. Okay. Now, they're not asking you for h prime at any x. They're asking you to order it at 6. So let's just think about each of those one at a time. If I wanted h of 6, look at your graph. Well, hold on. This is a graph of f. H of 6 would be the integral from 0 to 6 of this graph. So it's 0 to 6, correct. So how would that area come out if I integrated from 0 to 6 for h? It's going to be negative because where is the area? Below. Okay, then I go to the derivative. H prime of 6 would just be regular f of 6. And then I think, Elena, you said this answer earlier. What's f of 6? 0, because I'm on the x-axis. I'm right here. Okay, then your last question would be h double prime of 6, which would be f prime of 6, which is the slope. Look at 6. What's the slope? We don't know the number, but we can tell the sign at least. Okay, it's uphill, so we know it's positive. Which means then that we could put those in order from smallest to biggest. So we would want h to be the smallest, then h prime, then h double prime. What answer do we want? A, very good. Very good. Okay. I will make you do only one more problem. Okay. Look at this one. So skip a page. This will be our last one for today. Okay, look at your equation. Dy dx, blah, blah, blah. Okay. Then it says we have a particular solution with the condition f of 0 is 1. Okay, defined for all real numbers. Skip part A, we're going to do B and C. B asks us to do what? Okay, equation of tangent line, what are the two things that we need? Okay, do we already have a point? What is the point? 0, 1. Where will we find the slope? Okay, should I take the derivative? Or do I already have the derivatives? So if they gave me dy dx, I'm ready to just plug into this, right? Now let's review the notation. I want the slope of dy dx at 0, 1. Then I'm going to do dy dx, vertical line, 0, 1. Just like that. And now we're plugging in. So it'd be 3 minus y, which is 3 minus 1, times the cosine of 0, which is my x. 3 minus 1 is 2. Cosine of 0 is 2 times 1 is 2. So now I know my point. I know my slope. Then I can write my equation of my tangent line. What's it going to be? Okay, perfect. Do you have to put the minus 0? No. Okay, then it says write an equation for the tangent line. Check. Use the equation to approximate f of 0.2. What do I do with this decimal they gave me? Yes, plug it in. Bloop, right there. Okay, also make sure that if you had written your tangent line with that number already plugged in, you would have missed this point. Because it says write the tangent line, then use it. So those are two different steps. Okay, so we have y minus 1 equals 2.2 minus 0. What is 0.2 minus 0? And what is 2 times 0.2? 0.4, and then what do I do with the 1? Add it across, so my y is going to be you could do that. You're saying like you'd solve it into y equals mx supposed to be first, that's fine. Now, let's also say that you really just like stuck with decimals and stuff. From here, if you wanted, you could have just said it's 2 times 0.2 plus 1. That would still give you full credit. So like if you can't multiply these for whatever reason, let's say it's like harder numbers, you could literally just leave it just like that. So okay, we're done with part C. One more part left. We have a differential equation. That's dy dx. We want to go back to y. We want the particular solution. Are we doing a derivative or an integral? If we have dy dx and we want to go back to y. Okay, we need to do an integral. Now, if you remember when we covered this, you can't integrate with all of the letters jumbled together on. I know, this was the homework that really sucked. Okay, this is a minus, I just went to the slash. Okay, but you cannot integrate with all your y's and x's together. We have to separate first. So my dx is going to come over to be next to the cosine x. And my 3 minus y is going to have to multiply over to the other side. So I'm going to cross the dx out. And I'm going to cross the 3 minus y out. Now, I have to leave some kind of placeholder on top of the 3 minus y because I divided it to get it over here. What could I put on top? Perfect, a 1. Okay, so here's what we have now. 1 over 3 minus y dy. And then cosine x dx. On the AP test, at this point, you already got 1 point because you separated it correctly. Integral, then you'll get a point for each side that you integrate correctly. One of these sides is harder than the other. What's the easier side? Okay, cosine. What's the integral of cosine? We already know that. So snow cone. I want to go up, so I'd just be at sine x plus what? C. Don't forget your constant. Now, what is this side going to need? Because it's not a 1 over y. Substitution. Huh? So then from there, what's my u? 3 minus y. Then what's my du? The derivative of that. -1. And then remember, I'm going to times the dy up, and I'm going to divide the -1 down, so that dy is a du over -1. So now we're ready to rewrite this side. So it's the integral of 1 over u du over -1. And then where can we pull that negative? Just to the front. So now it's -1 over u. And that's one of your specials. What is it? Okay, what's wrong with how I wrote this? Absolute values. When you do a 1 over u, don't forget your bars. Okay, so then I'm just going to drop this right-hand side down. So it's a sine x plus c. What would I do next? Okay, I am going to put in my u, yes. But even before I do that, what can I just get rid of if I want to? Yeah, the negative. And how will I get rid of it? Yeah, just times the negative all the way across. But what do you not actually change the sign on? The c. So I'm going to multiply by negative across so that now this side is positive. But this is going to turn negative, and then this I don't care about. Okay, from here, the negative's gone. We still have to get rid of the LN. How do we do it? Okay, E both sides. And then do we remember the kind of funny property for logs that we can do with the C? Remember, it's going to drop down to the front. So here's what we have now. 3 minus y equals CE to the negative sign. Are we good to there? Okay, we're almost there. We have 2 more steps. We need y alone. What's the next thing that we move? Okay, subtract the 3 from the back. And then now it's a negative y. We need a positive y. So we go through and change all the signs again. But who do we not change? Nobody cares about the C. So my final general solution is y equals CE to the negative sine x plus 3. How do I turn my general solution into the particular solution that they're asking me for? Okay, so I'm going to use 0, 1. And then how do I do that? I plug in 0 is the x, 1 is the y, and then I'll find what my c is. So 1 is the answer. When I plug in 0 is my x, and then we're solving for our c. What is e to the sine 0? Yes, so the sine of 0 is 0, and then e to the 0 is a 1. So I have 1 equals c times 1, which I'm not going to put plus 3, which means that my c is a what? Minus the 3 across your c is a negative 2. And if I turn my AP test in like this, I'm not going to get credit plus 1. Remember, you need to write your full general solution with that negative 2. So my particular solution would be y equals negative 2 e to the minus sine x plus 3. So a lot of times if they put one this hard on there, that just part C will be worth 5 points. You'll get 1 for separating, 1 for the integral with the left side, 1 for the integral with the right side, 1 for getting to your general solution, and then 1 for getting to your particular solution. So you would get a point for separation of variables, which would be this. You would get 1 point for getting to here and 1 point for getting to here. Now notice both of those are antiderivatives. One of them was just hard, right? Then you'd get 1 point for getting to your general solution. And then also, I don't know if y'all remember, you don't have to move the plus C down. You can leave it up top and you would still get points. And then your last one would be for getting your C value. And then usually for the equation of the tangent line, you'll get 1 point for the equation and then 1 point for the answer. So you get 1 for here and then 1 for here. Okay?
And like this would be appropriate, like to write like this polynomial thing or like label your stuff.
No, as long as you're not, you know, just like leaving like here. If you just have like random numbers around it, I think you're gonna be in trouble. But you don't have to put like, now I'll use this point.
What are the topics doing in
Say that again.
You said the test grades.
They're major grades, yeah. You're not gonna have any tests this quarter. They're gonna go under quiz grades, but
What are they doing?
just the day they, everything's just due then. And then after that, we won't have anything to work on. So exemptions are per class period. So like if you're always late for first period and you have a bunch of absences, it would only affect your exemption status for that class.
When is the exemption date?
Yeah. And then you have to have an 85 average, but with quality points, that's only 75. So you basically just have to be and then I don't know though what the date is that it starts from. Have they told you?
I think it's a 3. That's what I thought. I don't know.
Yeah, usually it's like
They didn't pass over
February.
until like late.
Yeah, I thought that I emailed and asked that, but I don't remember. I never got a response.
Everything.
Oh,
Your van.
Oh,
Salutatorian, couldn't even get her introduction right.
And I started talking about it, and she's like, I don't know. So you kind of put me and send me in the van.